Okay. We got the cats. Look at them go. And now, so I think at this point, I know enough of like explored the space enough and sort of like poked around with like the different options enough that I can start thinking about the workflow, like the actual workflow that I want to use. I've flubbed around enough that it's like, okay, I think I see the routes, so I'm going to do some planning and sort of get down what all those pieces are and then organize them. Which is something I do, just to be clear. But it's not like I'm like, now I'm gonna like turn the crank on that. This is one of those things where I'm like, this is a thing where like the videos is like helping me because I'm like, everyone will be confused if I do something, so I should be more clear about what I'm doing. And then it's like, wait a minute. Usually I just would have powered through. So, cue Blink 182. Okay. What am I missing here? You know how to do this. I'm learning how to draw. You know how to do this. We've done this before. See? Told you. I like this quill. Makes me feel like a fancy guy. Okay. Z. Okay. So let's just write some stuff down for now. We'll start with... Hey, come on, man. Why gotta be like this? Let's pick a nice color. That red is too not chill. Let's pick this nice bluish purple. And I got one of these. Check fucker. Wait, okay, so I do this one, that's the one I want, and I click on this one, and now I got these on back and forth. Because this thing doesn't work, there's something, I don't know. Has something to do with Krita guts. Okay. So funny, like I can't, I'm like, if I can't see the edges in my head, I'm like, you're probably zoomed in. Can I zoom in out just a touch? Let's say, zoom out? No, that's too many. Oh, it's a smaller number though, so what's 40 look like? I need a little like mini map. Okay. That's fine enough. Where are we at now? 33. Oh, are you incremental? You fuck. No, you're not. Yeah, drop down? Yeah, I see that's what the scroll wheel does. I do. Let's take up the whole space, guys. Let's do it. No, that's too many. There we go. No, I don't. Oh, we're zooming with scroll wheel. We know that. Okay, whatever. Jesus fucking Christ. Wait, what are the keyboard shortcuts? I need to turn I'll just trust those. Zoom to fit is 2. Okay, so we are, okay, so press 1, and that's a 1-to-1. This is a 4K sketchboard. 2 is zoom to fit, and then 3 is zoom to fit edges. Cool. Zoom to fit. Let's do that for now until we've internalized it. Okay. So, what's the task? The task is cat mocap, and the end goal is one of these. We got ourselves a kitty, and it looks like this. I'll show you what it looks like. Okay, so we got the, what's it called? Is it the Frennet frame? I don't know if that's the Frennet frame. So wait, okay, da-da-da. I'm getting distracted, but I don't care because you're in my house, kids. Ooh, check this out. switching to a pencil for the sketching part. Okay, so here's, got these presets you see. So that's the origin. And then red is X. X. Zoom in farther. Ooh, now we can see the pixels. That's how we know that we're in, that's how we know we're in the good stuff. The shit am I doing right now? Or is that how they do the pencil effect? Is it just the pixelated? Oh, that's, it's just like, it's a Gaussian sort of, like it's a, when you click it, it plops a Gaussian at that grid, and then the fall off is the saturation, I guess, or the power. Small. Oh, still quite big. Oh, it's, come on, man. There we go. Could have Control Z too. Okay, now we got this, and we say X. He's got a little hat on because it's a unit vector. It's like orthonormal. It's a whole thing. Don't worry about it. And then X is red. 100 RGB X red unit vector. It's a whole thing. Talked about it before. So RGB. So Y is going to be green, which is not great for the colorblind, but you know, I'll label it elsewise as well. And I'm told that these like super saturated RGB reds and greens are actually easier to determine because their luminance is quite different. Like this is so much brighter than that. It's the sort of the ones that are more muted that can be harder to tell. Where it's like more in the chroma, I guess. I don't know. There's your Y. And then, of course, so 100 is X in 3D space. 100, that's the X vector. It's also in RGB space, pure red. 010, Y vector, also RGB, pure green. Me. Hey. Why? Come on. Oh, wait, no, I moved it. Haha. That's why. Someone came and changed it on me. That person was me. Now we got the Z. Ugly. Okay, so this is the rules. Right hand rules. X, Y, Z. So it's like this. So actually should be coming out from this way. Really? You don't say. Yeah, that would have been illegal. Oh my god. That was close. Whew. They would have got me. The right hand rule police would have come and fucking ganked me. The ghost of Aristotle cheering them on. We're talking about cats here, remember? In case anyone forgets. How do you make a Z? Rorudo? Ah! Z with a little hat on. Bad Z. Better Z. Yeah, could be better. Zoom out of it. There we go. You fuck. You motherfucker. Z. Yeah, there you go. That's a Z. How you like that? Boom. Got ourselves a 3D space. But why? But why though? Because I wanted to talk about the RGB thing. I'll be honest, I love that so much. Okay, so here we are in a 3D space. Because we're also defining the cat situation. What colors are left? Cyan, grayish cyan. Sure, dark grayish cyan. Sure. Okay, here we are. We're in a 3D space. We're now, see, you can tell it's 3D because of this guy, what lives here. And then in this space, there is a cat. And this cat, you see, looks a little something like this. Look at him. What a cat. God, it's beautiful. You can tell, wait, it's a cat, you can tell because of his claws. Nice. Fucking nailed it. And just to make it clear that we're scientists here, let's make sure to label that it's got a skull and bones. And that's it. That's a cat. And it's in 3D space. You can tell because it says right here it's 3D space. So this is the end goal. Remember what we're doing here. So where are we starting from? Are we at orange? Fine. Let's go back to quill. So no, actually we're still on pencil. And we're gonna do a more different color because we gotta use them. Weird. What do we got left? Not many. Let's make it this weird peachy color. Sure, why not? Okay. So basically, so in the world, there is such a thing you see as a real cat. And this real cat is going to look very similar to this guy. Actually, can I copy him? This will be good for, oh, that's going to be confusing for everybody. Who gives a shit? No one's watching. And if you are watching, hi, thank you. Control C. Control V. Huh? Did we do that? Did we do that? Can we? Not worth it. Great. Moving on. Wonderful. Where are we? What color are we? Perfect. Good enough. Now we have a real cat, and he looks like this. See, because I know you're like, this looks like a dog for sure, and I understand that you would think that that is a dog at this point in the artistic process, but then I'm gonna obviously zoom in and add some important details like this pink nose and the thing that where the mouth goes like this. I guess he has fewer big teeth. That makes sense. As based on what I know. See, this is why I don't like that. Ooh, too big. How big are we? Oh, that big. Okay, we watch out his little face. There we go. Perfect. And then we gets over here to Mr. Pencil. That's not gonna be right. E. Oh, jeez. Oh, I've ruined the world. What happened? Where'd you go? Oh. What has happened? What has occurred? Where did it all go? Pencil? That's okay. It was shitty anyway. Okay. We're getting too slurped in. Cat. Mocap. 3D cat. Real cat. Then this is the question. Right? Pretty straightforward. That is so perfect. I'm going to encapsulate it forever in its own layer, and we're going to work on top of this now in a new layer, I think, where we can say this, and the previous perfect incarnation of a research plan will retain its identity. We're gonna save this shit too, because apparently we have to do that. Wait, where'd you go? Did we not? Autosave. Okay, we do have an autosave. We don't need it though. I'll figure that out later. I'll lose some work until then. Oh, wait. More fool I. Why am I not getting a preview now of this shit? That seems bad. Cat Mocap. No, let's do aggressive. There we go. Cat. Spectacular. No notes. Perfect in every way. So, now the plan, if we convert to focus on it. So we got the cameras. And then the cameras feed in to videos. Gotcha. And then the videos have to become 2D data. That's like the tracks on the screen. That's the part. What looks like this free mocap. See, this is the part where I'm like, oh wait, why? I need a place where I can just go straight to and be like, here, look at the data. What the shit? Get the fuck out of here, you fuck. Like, this should have straight front and center, like, boom, skeletons. Skeletons. Do I have it drawn here? This is the 2D data. This guy. So it is a skeleton track on a two-dimensional place, right? You drew the stick figure over it. You could do it by hand, but you don't have to because the machine knows how to do it. This is like the most epistemologically sketchy, not literally, part of the process where this is the only part of the free mocap pipeline that uses like AI, machine learning, whatever. Stochastic computation is another way to think about that. And it will just get it wrong sometimes. Like the reconstruction, like the 3D reconstruction and stuff like that, it cannot be wrong. It is simply the math. So you calibrate the camera so you know where the cameras are. That part also has an optimization step, so it can get fucked up. But if it does work, but it has a direct testing methodology, so it can test itself with reprojection error. So you can trust the calibration step. Good old Lily Karashkik. Anti-pose still works quite well, even though I hate it. I don't hate it. I have a lot of complaints. I want to change everything about it, but it works very well. I should do that one first before moving into Deep Lab Cut because it's smaller and I understand it more. Anyway, so the detection of the person on the screen is the most epistemologically sus part of our pipeline, which is why it is good that it is also the most observable, because it draws a stick figure on the image based off the machine learning estimates of that thing, which means that you can just eyeball check it. Like you could do this by hand. That's how we used to do it, is by hand. And so because I can do it by hand, I can eyeball it and know whether or not the machine got it correct. And then if this part is done correctly, then the rest of it is like Euclid shit. Like it's not going to be wrong. So the question now we have from here is like, this is the real guy. This is what really happened. This is like the true fact of the world, is that once upon a time, my cat slipped on a slippery board and I got it on camera. The photons hit bounce off the light, bounced. A photon came from God, bounced off of Mr. Cat, who's a lady, and was absorbed by the camera sensor and was sent down. And the voltages on the sensor were logged in a file format that we call a video, which includes, as part of its raw data type, samples from the light field at regular intervals, little rectangular snapshots. And what we've got to do here in standard free Mocap pipeline, where are we going to? We're on the same. It's fine. Who gives a shit? Standard free Mocap pipeline. This goes into like a human tracker. Specifically, we use MediaPipe for most things these days, but we're adding your open poses and your YOLOs and your mem poses and your whatever the hell else. But a human tracker comes in, it gives us 2D data. It goes into the 3D generator or whatever, reconstructor or whatever fucking geometry things. Then we get a 3D human. Right? So obviously this is what happens, right? Basically the human track is easy. So the part that we need to reconstruct in cat land is this part. The part where we go from the raw videos of the cat, which are, we haven't synchronized them yet, but we'll see, we know how to do that, so we'll do that later. And then to get the equivalent of the 2D data of the cat, which is pixel coordinates. And then that, once we have that, then the rest of the pipeline should work fine. There's a little bit on, there might be some little bits we find out that are sort of tuned for human, but we'll get there. Wee, bye. Oh, yeah, bye to you. So, lock 'em again, Sam. Probably a keyboard shortcut for this. Anyway, new color? Perfect. So now the most desired, now the route that I had thought I was going to take was a direct route through, okay, actually, Mr. Question Mark, you are not pulling your weight. You must be excised from this world. Bye. Ooh. Bye. Okay. Bye. La 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 la. So the route that I was going to take, the most direct route, is through Deep Lab Cut. Good job. Ah. I have done this before, and it works quite well. Oh, actually, I can even point this out. Like, so see how there's two skeletons overlaid here? Like, this was from a time, one of the only times I can recall, when this is MediaPipe and OpenPose on top of each other in the same video. We've only done this like once or twice before. It's a proof of concept, and we're just now getting to the point. This was 2021. We still called it. We've learned so much. Yeah, so this was one of the first ones. It's back when I still put the board on the wall. Same board though. So these juggling balls are being tracked with Deep Lab Cut. I've done that before, and it was just like kind of a proof of concept, just because it's a good thing to mocap, and also it was a proof of concept of like we can put things in here that aren't human. So the pipeline works, but it's obviously way easier to track a brightly colored spheroid than it is to track a one of these. And so because it was so much more difficult, what I discovered here is that I don't really want to use the standard pipelines of Deep Lab Cut because I have learned so much since I was last in this space that I don't really trust a lot of their pipelines. Like I trust their core functionality because I've seen it work. I know that it works, and I dove deeply enough into their docs and their guts of their code and blah 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 that I'm like, okay, I get this. This works. I can write code using this package that will do the task that I want to do. However, there's a little bit of flimflammery and pre-processing, I guess, is where we're at now. Because I don't want to just dump the videos in, follow their standard pipelines, and get the 2D data. I don't think that's the best route for me. It could work, but I think it would wind up being very effortful, and ultimately like bonked effort, like not worth it. Like it wouldn't add to anything after itself. It would just produce the output quickly, which might be what old Ben Scholl wants, who's the guy who's sort of. He's the one who's. This is in service of his goals, because he is a researcher of small quadrupeds. So I asked him earlier, and I was like, asked him what he's giving a talk on the 7th, which is what, Thursday? Yeah. So I could get him the 3D cat by then, but I feel like that effort would be better suited, like making the pipelines better. But it sort of depends on what he's looking for. Like sometimes the manual effort solution is the right solution because it's the best way to get to the endpoint. And if you're trying to establish proof of concept, that is critically important. In my case, I think because I have so much experience with this stuff that I've already hit proof of concept with this. In pushing it through to the end, I don't think I would learn all that particularly much more. So, in a world where we are happy taking a little more time, what we shall do is, with a yet more different color, we shall talk about the stuff we shall heap upon said friendo. What are we gonna color do? What are the colors? We got green. We got a whole green space. Great. Do we have greens in here? We don't. Yeah, got a whole green space left. Oh, could I have like a little color thing? Can you just show me that? That'd be dope. Do we have one of those? They call them Dockers because it's Qt under the hood. I think it's a C code, C++ Qt. Dockers and Dockers is what they call the movement. These things are docs in Qt language. In the Qt ontology, these things are called doc widgets. And so they call them Dockers, which tells me that name was chosen either before Docker became a super standard thing in software development, or that name was chosen by people who don't know how to use Docker and don't use it regularly in their lives. These are the little this is the cultural anthropology part. This is the part where you're like, it's like, oh, you're using that term. Was that tag available in your lexicon? Oh, okay. Wow. I see where you got it, but I wouldn't have called it that. I would have called, I don't know what I would have called them. Those aren't free Mocap yet. I tried, but they're technically in there, but they suck. They're probably using the advanced doc system or whatever, which is like it allows it to be more robust than the standard Qt docking system. Anyway, as we were saying, obviously keeping directly on task, I wanted to see if there's like a color picture thing. Histogram. Yee, give me histogram. Well, no. I mean, it's okay. Always want a histogram, but we'll get there. Fuck off. Thank you. So I think the move is that we do a pre-processing step of cat cropping with transformers, which is this, which we already did that. What else did I do? Oh, I did come up with like in my explorations of Deep Lab Cut, I discovered a lot of things and sort of like, it's like, oh, like there's, yeah, I don't know. It's prodigal son vibes. Like I'm coming back like, oh shit, I know things now. Before I was just learning, but now I actually know enough to contribute to the conversation. And one of the things is like, you need to base your models on biomechanical constraints. That is a strong hard line. I will say, if you are tracking an animal or an object, you should utilize the massive power that you get from rigid body constraint, the assumption of rigid body assumptions, both in terms of like what you get computationally and also what you get in terms of like instructions to people. Like, what is your task in this moment? Shooting a laser through the anatomical landmark that you are tracking, I believe, is very important. And I will eventually build a sort of my own tracking methodology that directly uses these constraints of these are rigid connections. The distance between them must not change in 3D space. These are non-rigid connections. The distance between them shall be bounded in 3D space. And these are mirrored connections, which I don't actually know what this will tell me. I just mostly needed to represent it because I realized that not all dots were on here, and that's ambiguous, and I don't enjoy that. Also notice I'm not labeling right and left because I'm assuming that you, the human person, can figure that out. Also notice that the right side is the red spaced color. It's magenta in this case. Right is red. Red is right. Right, red, red, right. If you have a choice of colors, the right side doesn't have to be red itself, but it should be red family, like red, pink, orange, whatever, red, pink. And then the left side is going to be some other thing. And then the middle, like if there's an axial, it can be any other color. And don't use red, green as your main color space distinction. If you are normally sighted, typically sighted, it will be the most obvious one for you. It will be the one that cuts the deepest across the broadest lines of the color space. But if you are colorblind, this is nothing. And so no matter what, no matter who you are, don't choose the one that will immediately cut out 10 to 15% of your audience. Just pick a different color. Red, blue, blue, yellow, cyan, magenta. Like there's plenty of other colors. Just don't use hard red, hard green. There's other types of color blindness, I think. I actually don't know them off the top of my head, but red, green is by far the most common. So, and like there's only so many colors. I guess also don't use color as your main distinguisher. When possible, don't use color as the main distinguisher. In this case, you get a little bit from the anatomy, but anyways, moving on. But yeah, the things we've learned going in. But this was sort of like when I realized I could not use their pre-trained cat models. That's why this was an important distinction. Because they have like a super animal model, they have a pre-trained cat model, like MMPost has a pre-trained cat model, and clearly none of these things were built with the skeleton in mind, or at the very least, not at the people who did that do not have the same personal affiliation with skeletons and skeleton-based reasoning that I do. Shockingly. One of the weird things about growing up and being a scientist and being a researcher and being a professor is like you really have to come to terms with the fact that you do have something to contribute to the conversation. Like when I walk into a space and I'm like, why aren't they doing it like that? Like historically, when I was like younger, when I was a student, when I was less percolated in the particular subfield in question, I would just assume that I'm missing something. Like you are doing this for a reason. I am missing it. I must figure out your reason because no matter what it is, it's better than what my idea would have been. Which is a good way to be. And it's a student mind, and it's a good way to go in. You have to go into that mind every now and again. But sometimes you just have to learn. Actually, I'm sorry. I know what I'm talking about here. I am the expert. I am the authority. And no matter what reasoning you had, which, to be clear, I really want to know what that reasoning was. But no matter what it was and how valid it was and whether or not it's valid, I have my own approach, and that is correct to the extent to which we can trust my expertise, which I can give you the credentials. That's my dissertation, actually, or my diploma. That I'm here to tell you this is a better model than the one that you're using, within the constraints that I care about. Sorry. I know things. I have to internalize that. I do no one any favors by pretending I am not super good at this. Okay. What the shit even am I doing right now? Yeah, so videos, pre-processing. Excuse. Pre-processing, get the... get... me. Meow. Wait, no. We got the little cat. We cat the crop. See? Look at this cat. He's cropped and ready to go. And then I think then we will load those into Deep Lab Cut. They have their own cropping method, but I don't trust it, and it's super not observable, so I don't know what the fuck to do about it. Like, I don't know how it works. Their documentation is kind of confused and confusing. It's interpretable, but I don't like it, and it makes it sits at best as a fuzzy point in the pipeline when I think about their pipeline. And that means I don't like it, because it means that I have now added a blurry patch to my mental model of what's happening. And this is not a dig. I understand why it is that way. I would love to help fill in that gap, my perception of that gap, whether or not it is real. And I will at some point, possibly with their blessing, possibly in parallel. I do not no divergence. I don't want to fucking do that. I'm not going to publish any of this shit. Someone else might publish it, but I'm not going to publish a methods paper. I'm just not into methods paper. Just fucking describe it. Ugh. Put it in a repo and shut the fuck up. Well, I mean, I'll shut the fuck up, but like, people who are telling me to publish papers on my methods, you shut the fuck up. It's a waste of energy, and fuck the journal system. And at best, I get to put out an artifact which is instantaneously obsolete. And I don't trust people who be peer reviewing it. I don't fucking trust their opinion. Who the fuck even are they? Okay, focus. So it goes in here. And so we just load the images in. We'll get to the code stuff in a second here. I'll do this, actually do this via the machine. Give me another color. And what color are we? Let's go to dark blue. Can we see this? It's a little... I think we've earned a little red, don't you? Okay, so... And then, so we put it in Deep Lab Cut, and using the functional GUI that does its job well enough for me to use it, we will label hits. I'm not going to be using their GUI for this workflow. This is partially so that I know what code to write, because they have their click button GUI, and it does do the job, and it's great that it exists, but it also sucks shit, and I hate it. And it has like a strange smattering subset of the available options on it. Again, super unobservable. No fucking log. You click the button, and best you can get is a completely raw TQDM thing. That I can fix, and absolutely will. I will fix that while I'm doing this, because I can't with the black boxes. I know that the key is available, but it needs to happen while I'm using it. Click the button, give me a log, for fuck's sake. And I can, that's easy. I'll just do that. That's easy peasy. Label the cats. This is okay. This is another standard pipeline. So it's like, shit. What is it? I know this. Deep lab cat and deep lab cat, deep lab cat and a keep lab cat. Oh, and I'm gonna put this. This is gonna be like a free mocap repo or something like that. Oh, well, okay. So we got these steps. Aaron has his, but this is mine-ish. So we don't need to do extract frames, thankfully. We do need to label frames. I guess we'll use check labels, but it's fucky and not particularly useful because it's it gives you a view that the fucking default should give you, which is the skeleton connections between the points. And like, if when I remake that, it's gonna have that. That's not enough. We're gonna have to have a label. Like, if free mocap is going to have a deep lab cut connection, I'm going to have to recommend that people use deep lab cut, and I cannot recommend that they use deep lab cut as it exists. I think that's maybe where we're at. Is it runs afoul of, first of all, my desired workflow, me personally, but also like the universal design aspect of free mocap. I cannot in good conscience tell people, hey, go use deep lab cut, it's great. What I can say in good conscience is, listen, if you go and figure out how to use deep lab cut, it will help you do amazing things, but it itself is a perfect example of the reason why I chose to kill my career in order to make free mocap what it could be instead of what it would become if I tried to build it while also maintaining an academic career. Believe me, I understand why deep lab cut is the way that it is. Also, that's why I want to come. I would love to help. Me and Skelly would love to help. We'll talk about it later. Moving on. Let's keep this under an hour. Label cats. Check labels. Maybe I'll check what the parameters are. I'm not gonna check the labels. I'm just gonna have to trust my gut, because I'm not gonna add that into the workflow of like fucking. Like sorting through these fucking images and be like, are any of them right? So I'm so salty just by default. Okay. Label cats. Yeah, okay. And then create training set. Create training data set, which I need to look into what actually gets done there, but it's pretty stupid. It's pretty straightforward and dumb. It's like here are the images that you labeled, and here are the pixel coordinates. It's like a CS. They use HTF5 for some fucking reason. I don't know why. There's presumably some fucking value to it, but it's just like, I guess it's database like. I don't know. Like they are like HTF. Like maybe do they put everything in the HTF5? I don't know. Unobservable. Rah. But it's like, here's the images, here's the pixel coordinates, and then they have like, and then this is where their real their cool stuff comes in. Is they're like, they have, I think it's the image augmentation step is their main part, is like their main contribution. Probably also their architecture, but I don't know enough about neural networks to know. But the image augmentation step, like they take your stuff and they fiddle faddle around with it and sort of like expand it out, like stretch and skew and like crop stuff out and blur it, and sort of, so you can like it multiplies your training set by a lot, which is neat. So when you see imaug, that's what they mean. Yeah, that's right. The biggest, arguably, to my understanding, one of the biggest contributions of their workflow is called fucking imog. IMAUG. That's what they... I'm so glad you saved all that time in typing. I'm sure you used it wisely. Train network. Train network. This is the part that takes a long time. This is why the cropping is such an important step. Arguably, it'll make the labeling easier for sure, but also it'll be less data going into the trainer, which means that my GPU should be able to eat. It'll be able to train this much faster, which is important because there's now a loop. I don't think evaluate network does anything useful for me. It just prints a bunch of shitty raw fucking poorly labeled static fucking matplotlib pings, dumps them into a fucking folder with no explanation. Great. Thank you. Super helpful. Really useful. I'm so glad you did that for me. The fuck even? What even? It's probably in the paper. I have never read that paper start to finish. It is too fucking boring because you don't talk about the things I want you to talk about. The whole fucking thing is validation. I trusted it when I saw the gif of the mouse grabbing the thing. I didn't need all that other shit. I need you to explain your fucking API better in a clean way that is a simple on-road from the instant. Just edit the text after you've written it. I understand why you haven't. It is not rewarded, and you do not have the available effort. But I have opinions. Okay, fuck off. All right, so once we've trained it, then we have to analyze the videos. And then we're getting weird here, but that's okay. And then we have to this fucking shit too. Filter predictions, like what is it? Arima, I could look into that. I don't know if I want that. There's like one part in their docs where it's like recommended and nothing else has recommended on it. And it's like, why is it recommended? What do you recommend it for? What's the purpose of it? What will happen if I don't do it? And what will happen if I, and what's the cost of, like, it was written by a student one time and never edited. You can tell because of how it is. Anyway, moving on. Plot trajectories, I think actually it's not necessary. It can be useful because you can see if they're like they start to get more coherent. But I'd rather see a video. This is also where like the lack of observability comes in. Like, what's happening in here? What are you doing in this step? This is the problem with like the pure file system approach. Is like it's changing data and files on my machine, but I don't think it returns it. So again, observability is not. Okay, I'm gonna say fuck the prediction filter for now, and I might eat those words later, and if I do, I'll just uncommented it. Okay, create labeled. Yeah, so here, okay, so this is create labeled video. And this is technically an optional step because nothing later will rely on it. But it's important for the human eyeballs to see because we got to see the dots on the screen because this is where we get to use like the beautiful magic of the human gut check to say, well, I have actually, what are we talking about here? Like 450 million years of evolution training my object detector to tell me for sure that this is where a shoulder is. And so I can now look at this with my magical human eyeball brain system and say, correct, you did a good job, machine. You have in fact done the task successfully, and I will accept your response. But that gut check does not produce data. This is like one of the big this thing that's happening in computer vision, machine learning, blah 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 right now, is video has always been a strange form of data because our ability to intuitively understand what's in it is so fundamental and so easy that the ability to extract qualitative data, meaning the quality of it, like, oh, this is a good video, oh yeah, or like quality, like, oh, he's juggling, like sort of stuff like that. Like a human could sort of tell that instantaneously, but getting quantitative data out of the same data type, which is images and videos, like you have to invent artificial intelligence and computer vision and machine learning and like it's crazy to do that. So that's like one of the big revolutions right now, is we are now approaching the ability to easily and reliably extract quantitative data from images and video, which is historically qualitative. And one last little dip, one last layer down this rabbit hole. Nikolai Bernstein, old school guy, OG, like Soviet era researcher. People talk about Muybridge as inventing motion capture, but he really just took a picture of some horses. I would say he invented motion capture. And he did this by just marking on like a gel screen to track the wrist and the hammer of a blacksmith in like the 40s or something. Which actually, the concept of who invented what is just like racist. Just yell something's racist every now and again. Okay, analyze the videos. Extract outlier frames. Is that a necessary step? I think it does. I think it is. This is another thing I don't love because it has another, it's like I also it's just it needs to be rewritten from scratch is the thing. It needs a full from scratch refactor in order to be what I think it could be, taking the route that I think it should to where I think it should be, which may or may not align with the people who are actually the owners of this project, which is why I'm always very dodgy about no, I'm not actually always. I just like shout loudly about my opinions, but I try to walk it back. So it's a necessary step. I think I know how it works, but it's like they have all these options, and it's like oh, use k-means clustering. It's like it takes hours. Why does it take that long? I don't think it should. Or like use the manual method. It's like I don't know if that works at all. So, but I can make it do. I can make it happen. And it gives you that gives you the ability to have like it gives you the robot predictions, and then you can come in as the human and correct them and then retrain the model. Ooh, nice. Cool. Okay, yeah, you extract. There we go. Now we're in the loop-de-doodle. So we extract the outliers. We refine the labels, which is very similar to this. So I'm actually going to, how do I tag manual labor? There you go. Hand. Is that how hands work? Some sort of branching network? That's not right. Sorry. I was used to drawing trees right now. So thumb, finger, 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 finger. Great. Dang it, it's a tree again. Shoulder, elbow, wrist, thumb part 1, thumb part 2, thumb part 3, and then 4 more times. Dang it. Fucking. Focus, fucker. This is a hand. He's poking at stuff. He's poking at a screen. You can see. I don't know what I'm doing. Okay, label. You refine the labels. It's very similar to these two are very similar, but they're not the same because this one does not have machine labeled data. This one does. Oh, and there's a fucking bad bug here, where it is very possible if you go through and delete all of the machine labels and then save. Wait, if you go through label some, save it, it will dump out to HD5s and CSVs. And then if you go back in and delete a bunch of other stuff and then save it again, it doesn't see any new data, and so it doesn't update the stuff. So if you then go on to the next step, it will have all the garbage machine labels in there, and it will list them as you have. This is the human has said these, like because when you the refined data is going back into the training, anything that you save out of here is deemed to have been approved by you. So there's a very easy bug to like a very easy just like workflow mistake. It's not a workflow mistake. It's a broken part of their code, where it's very easy to get to a place where you are feeding garbage into the training model. It's like you are feeding in specifically the machine labels that you deleted into their training network, and there's no way to know that other than the fact that the label data, the videos will not get better. That's fucked up. That's a problem. I need to tell them at some point, but it's just like it's like someone else tell them, please. Verify that what I'm saying is true and then tell them. Deep Lab Cut, GitHub. I don't know. They're nice. No relation. Okay, refine the labels, and then I think. Oh, then we got to merge the data sets. I don't know what happens in this step. But I think it's I don't know what's being merged. Yeah, and then you create the training set again, and now you're in. This is now the loop. One hour. I did it. I recorded. I did it. I said everything I needed to say in less than an hour. So yeah, and I'm not gonna say anything else because if I do, then I will be stuck here forever. Okay, I'll come back probably later today and start. Okay, so actually, workflow-wise, I have everything needed to start this process. So I just need to start labeling the cats. So oh my god, I desperately want to be done in 90 seconds or less. Oh my god, no. Oh no, where are you? Oh, there's a thing, the lady on, I just watched a video. What is it, Control R? Damn it. Who are you? Who's Mr. Green? I made a mistake. I'm sorry. Is it you? It's you. Oh God. Oh dearie me. Life and space and heaven. I want to be done. I only have 1 minute. Oh dear. Fuck. I gotta. Oh no, you goddamn piece of shit. Give it to me. Delete your fucking body. Oh, you fuck. Oh, you fuck. Wrong one. Wrong. Top level? Great. Thank you. Select them. Fuck whatever this red scratch is, we're not fixing it. Okay, and now here we are. We're gonna do that, and we're gonna say, is this gonna do this? You fuck. Okay, and click that. Boom. Done. 30 seconds or less. We're out. I did lie though. Where are you at? Save. You see, something I like to do is like I set a hard deadline for myself, but then because that stresses me out, even if I hit the deadline, fuck you, I'm gonna go a little bit over because I don't like it when you tell me what to do. Me from the past. It's called self-care, and it's very healthy. It's not. Well, it's a balance. Talk to you later.